Hi everybody, I'm Manuel Paiuca and this is the project for the course of Artificial Intelligence for Video Games at University of Milan. It consists in the implementation on the development of a linear system for the generation of tree. Let's see the code. Essentially, we have three major classes. Ignore the camera movement since it is not important for the aim of the project. Essentially, we have the L system generator class, which is attached to the object origin, which is at the base of where the tree has to be generated, and it is the center of the settings that we want to set, that we want to consider for the generation of our trees. So there are many serialized fields to consider, and it uses mainly two other classes which act as a component of these major classes. I choose this approach because I wanted a linear code in the L system generator class, and I use the solid principle of the software engineering fundamental. Okay, the derivator class will start from a given grammar selected from the user in the L system generator, and it will generate a final string, which is the well-formed formula, which essentially each character, each symbol of the string will have a corresponding instruction to do, and this instruction will be deployed then to the parser. The parser will take the responsibility of each symbol of the generated string and will do a responsive action. So essentially, in the derive method, we will just have two nested loop, and we will keep subtracting in each one of these X symbol in the grammar. In this X symbol of the grammar, which is the axiom, we will keep do a substitution of the entire word, entire string. So it will keep in the same stream. It will keep recursively expanding this string, and this is essentially what a parallel rewriting system does, which is different from a normal grammar evolution, which in the normal system it will just apply the symbol after the axiom, not at the position of the axiom. So we do this kind of recursive substitution, and we will give this derived string to the parser. The parser will receive this string, and then it will just operate each case switch and doing the correspective action. So the axiom in this case is ignored because it's not relevant. Then we have the F symbol, which will generate a branch, and this branch will be generated respect to the actual given information of the direction, which can change. We will see how soon. The R is the counterpart of F. It will generate a root instead of a branch, and it will go downward instead of upward. So this will make grow the tree upward, and this will make grow the tree downward. The L will be used when we want to generate a leaf, and it is usually after an F symbol. On a terminal branch, we will have a leaf usually. This asterisk is an important symbol because we'll do a rotation of this current direction of the transform of the L system generator. So this is what I meant from actual direction. The actual direction can change in a random way through this function. I can't go in depth for each function. There is the GitHub repository for that, but their intuitive code is not really hard. And then we have the bracketing system for giving a different state for each level of our tree, so that we can go back at each level and reuse the information, the latest information that I put in that specific level of the tree. This way I have a saving system essentially for my informations. Down we will have these many data structures for doing the thing. The state essentially is what being pushed and popped inside our bracketing system, with our bracketing system, and contains the information of our trees. And then there is the operation that we can see how the tree is being developed. Essentially, in the start method, we buffer the system data, which essentially is what allows us for doing for checking if our tree is being changed. I use the buffer memory. I initialize the random seed. The tree rules are being set, and also the initial state is being set and being pushed to the stacks, to the stack of the states. Then we generate the branches. And we res to origin position, which is essentially this. Then we generate the roots and we res it to the origin position again. And then we assign the branches and root nodes, which is a really important function for organization of the application. Essentially, you can see that each branch is inside a branches object as a child, and each terminal branches has got as child a leaf. Okay, this is it. This also happens for roots, but there is no leaf, so will be only the roots. And that's it. Let's see how it plays this application. So essentially, we go on origin, which got the system generator script, which all these vector variables. We can go in the game mode, where there is camera movement enabled with a script. And essentially, we have a seed 14, so if we change it, go back to 14, we will always find the same generation. And there are different initial set of our grammar for having different trees. This in particular has no leaves, and can really show how the structure evolves. And we can see the width of the final terminal branches totally different from initial branches. This, thanks to the bracketing system, can enhance the natural looking of the tree. The same happens for the roots. Of course, we have to go underground for see that. And these are for the roots. And we can also pick up the length of the whole tree, which changes, of course, and the iteration of the derivator. This is essentially what the application enables you to do. And the final thing, we can show the free editing button, which once it is enabled, you can edit both the initial root and tree model and apply some symbols. Of course, the symbols has to be inside the parser, what the parser can read. Of course, this has to be one of the symbols, otherwise it will throw a invalid operation exception. So we can put the L. In this case, I have put some leaves. Of course, this is not a grammar that support the leaves, because we have leaves between the branches. It's not really it is not really realistic, but for the scope of the project is fine. So we can add something totally random like that, and we can see that the grammar essentially is respected, the physics not. yeah, and it will grow in something that is not completely a mess, but in this case, if you want to revert to a grammar that has a sense, and the default grammar have a whole sense, we just have to flag out this checkbox, and we go back to the original grammar, but for the root that for the branches. Of course, you can still play with the game. Some evolution of this application may be adding procedural evolution of the textures. Maybe the textures of the final branches is different from the initial branches for the cortex, for example. And maybe a more natural evolution of the roots, which is really similar to the tree, even if I put a sort of boundary which is like that to the point 0, -1, 0. There is a plain boundary where the branches can't go upward, and this is it. But this is because I understand recently that the tree doesn't the roots of the tree doesn't evolve much in the depth, but much more in the breadth way, so in widthness. For this project is everything. Thank you for following and watch this video, and bye bye.